Hello everyone, welcome to our project, which is how to produce product from petrochemical. First of all, what are petrochemicals? Petrochemicals are chemical products derived from petroleum. Natural gas is one of the petrochemical products, so in our project we will show how the purification of natural gas is carried. There are few separation processes which is involved in purification natural gas, which are solid discrete process for the removal of water, rejection expansion process, absorption process to remove carbon dioxide and sulfur.
Okay, so now I will proceed to the solid desiccant dehydration. This is where the process of removing water vapor from gas stream to get a low dew point. This is because hydrate gas have high pressure and low temperature, and it can cause freezing and blocking the pipe's valve and other components. Okay, so the gas will enter from the inlet separator. This is where the free liquid and solid will be removed. So the gas will enter in the tower. The tower full with desiccant bed, where the desiccant bed will remove hydrocarbon and water from the gas stream. After the gas stream touch downward toward the tower, the outlet gas will be wet just like the inlet gas. This is where the tower must be switched from the absorption to the regeneration. This is the regeneration tower. Before the desiccant bed is completely saturated with water, some wet gas is heated with high temperature to remove previously water. As the temperature increases, the water captured by the desiccant turns to steam and is absorbed by natural gas. The gas leaves to the top of the regeneration tower and go to the cooler. The water is separated in the generation gas by the separator, and then the dry gas will come back to the absorption tower.
Now let's moving on with the absorption process using the select solvent. Initially, natural gas contains significant amount of carbon dioxide and sulfur. If the amounts of carbon dioxide and sulfur exceeds particular percentage, it is considered sour gas. Sour gas is harmful and corrosive and somehow lethal even for breathing. The presence of hydrogen sulfide with water damages the piping and other equipment. And also the presence of carbon dioxide causes the bottlenecks, corrosions, and also the environmental hazards. There are several processes can be applied to remove carbon dioxide and sulfur. For example, sweetening the gas or amine process. And the one we are introducing you is the Selexo absorption process. Here's the diagram of the absorption process. Now we're starting with the sour gas here, flow upward the counter currently to the lean solvent produced at the top of the produced at the top of the absorber. The rich solvent leave the bottom here and flash in high pressure separator. This is the high pressure separator. And then after that, the stream is recycled back to the tower to reduce the hydrocarbon losses. The rich solvent from high pressure separator will be flashed in an intermediate pressure separator to release major portion of carbon dioxide here. Here's where the carbon dioxide is being released. The discharged solvent is pumped back for contacting the richest part of the sour gas here. It is pumped back to the tower. And then the process still operates until it reaches the desired specification. Now we move on to the advantages of select solve process. These are the advantages, which are heat produced is low because this process involved no heat, no reaction. The second one is it is low corrosion rate, and also it can be operated in low pressure. And the disadvantages of the absorption process here is the solvent has high affinity to heavy hydrocarbon, will increase the loss of hydrocarbon, which is difficult to be recovered. And then the second one is the process should be operated more efficiently at high pressure.
Hi, I'm going to briefly explain about the cryogenic expansion process. Cryogenic separation is a processing operation that is commonly used to extract natural gas liquid from raw natural gas. Essentially, cryogenic processes consist of the dropping of the temperature of the gas stream to around -120 degrees Celsius, degree Fahrenheit. There are a number of different ways of chilling the gas to these temperatures, but one of the most effective is known as the turbo expansion process. This is the diagram for the turbo expansion process. In this process, external refrigerant is used to cool the gas stream, which occurs in the gas exchanger. The purpose of the cool separator here is to prevent the liquid stream from entering the turbo expander. The turbo expander is designed to sharply drop the pressure of the vapor, which will cause an extreme temperature decrease of the gas stream. Cold gas stream enter the cryogenic tower. To separate the methane from natural gas liquid, the liquid mixture is passed through an additional chamber, which is the demethanizer, this one, where it is progressively warm. Since the methane has lower temperature, which is -162 degrees Celsius compared to other hydrocarbons, methane will vaporize and leave the tower here all the way back to the compression process, and the liquid, natural gas liquid will be extracted from the demethanizer. There are a few advantages of this process, which is the ethane recovery rate from the gas stream ranging from 90 to 95%. Cryogenic separation is typically one of the most efficient methods of natural gas liquid extraction. Okay, the extraction of natural gas liquid from the natural gas stream produce both cleaner, purer natural gas as well as the valuable hydrocarbons that are the natural gas liquid themselves. The expansion turbine used in the process can configure to harness some of the energy released during the expansion process to recompress the gaseous methane effluent, which ultimately results in lower energy costs. There are also some disadvantages of the cryogenic expansion process, which the high energy is required for the regeneration, and also there are tendency of blockage.
So now we're moving on to the final part of our natural gas processing slide. So this part consists of number 1, sustainability, which involves cryogenic absorption and solid desiccant dehydration. Number 2, the environmental impact of natural gas processing. And number 3, the reusability of waste products from natural gas processing. First of all will be the sustainability part. Sustainability usually involves on how we can use a certain product for a long period of time without affecting its economical value and without affecting its cost. First part of this slide would be waste management. Waste produced must be treated and recycled and reused to save costs. The second part would be energy consumption. We need to maximize the energy usage without any wastage to save operating costs. Number 3 would be environmental impact. Byproducts released must not be harmful to the environment. And the last part would be manufacturing costs. Steady systems with efficient operating system to produce reliable and cost-saving products for a long period of time. Next, we will move on to the environmental impact of natural gas processing. The first one would be rise in air pollution. When a certain process is carried out, particularly natural gas processing, a lot of harmful gases such as hydrogen sulfide and carbon dioxide are emitted to the open environment. These, on a long run, can cause global environmental impacts such as global warming. Number 2 would be the harming of wildlife and domestic livestock. When animals out there inhale such air pollution, they can be infected with various diseases, leading to an extinction in their population. The last part would be water pollution. When such harmful gases released from natural gas processing, such as hydrogen sulfide and carbon dioxide, are dissolved in the water sources, they can cause an environmental impact. In such a way, they can kill aquatic livestock. Remediation, which means to make better soil, to clean the soil. The second one would be hydrogen sulfide. Hydrogen sulfide is used for the production of elemental sulfur and sulfuric acid, which is primarily used for contact process. And last one would be excess water. Excess water can be used to treat domestic usage, and it also can be used for cleaning purposes.
Is this the real life? Is this just fantasy?